Today we're going to be looking at the calibration on a MENC004 120A. This is a 120 volt actuator, proportional control. It's set for 4 to 20 milliamp analog signal input and 4 to 20 output, running in direct acting format. So this is a 445 inch-pound actuator, and the C model has an additional piece on the bottom, and that piece is actually used for a manual override that's on the side of the actuator. That's a 5 millimeter drive, hex drive, and that allows you to position the actuator manually when there's no power on it for manual positioning. So what happens here is this actuator, because it's got this additional piece on the bottom, the indicator shaft, the indicator shaft, and the cams rotate in an opposite direction from the output shaft. So all of our actuators operate clockwise to go in the closed direction to close the valve, clockwise to close, and you can look at the visual position indicator in the top of the shaft looking above the actuator on all of our actuators, clockwise to close. This model here, the C004, this model is the only one that we have that operates opposite direction. So even though the valve is still turning clockwise to close, the indicator shaft and the cams and everything above this point here are rotating in the opposite direction. So valve clockwise to close, indicator shaft is going to run counterclockwise to close. So that's just a word of caution when you're dealing with the C004 series actuator. And the reason why that's important is it affects which direction you want to move the cams to make the actuator respond properly. So we've got this actuator powered up, 120 volts out of the test box, feeding terminals 4 and 5 on the actuator. And we've got an analog signal being generated by our little signal generator here, showing 12 milliamps, approximately 50% of a 4 to 20 signal. And the actuator is roughly in 50%. And looking at the valve itself, you can see the valve is about 50% open. So everything is good in that respect. So let's go ahead and check the full open position. We're going to generate a 20 milliamp signal on the signal generator. The valve is going to be going further open. Indicator shaft is showing moving towards the open position, and it stops. So what that tells me is the actuator is receiving a 20 milliamp signal, but the feedback is only showing 18 milliamps. And if I look at the valve bore itself, you can look down inside and see that, in fact, the valve is not fully open. So what I'm going to do is I'm going to cut the power to the actuator, and I'm going to use the manual override shaft to put the valve where I want it to go. So looking here, I'm in the 20 milliamp position. I want the valve to go further open. I'm going to rotate this shaft in the counterclockwise direction to drive the valve to go to the full position that I want it to go to for open. And that looks just about right on the money where I want it to go for full open. You can see down in the bore the valve is fully open. I'm going to leave the power off, and I'm going to adjust the cam that's going to tell the proportional controller when to stop. It's looking at the cams to control the positioning, the end of travel of the actuator. So clearly what was going on before is the cam was set to stop too early. Now, in looking at the wiring diagram, we can see that the full open position is the number 1 cam, and that's going to control our full open position. And looking at it, we see that the lobe approaches the cam switch from the left side. So I'm going to take a look at the lobe on the cam is going to be hitting the limit switch from the front side of the switch as far as it's concerned on the actuator. So the number 1 cam, I can see this is the counting from the bottom, our number 1 cam, and I'm going to move this off switch because it hit the switch too early. And if you listen carefully, very light, but that at this point right there is where it hit. So you can see that originally this was over here, which means the cam was set too far in that direction and it was stopping too early. So now I've got it set so it should stop exactly where it's supposed to. I'm going to power it up and check to see where the unit is now. So I'm going to go down 25%, give it a reduced signal and let the valve close a little bit, and then go back to 100% and see where it stops in the full open direction now. Okay, and now we can see we're at 19.9 milliamps on the feedback. I can look at the bore of the valve and see the valve is in fact fully open where it stopped. So now the next thing I'm going to do is I'm going to calibrate the analog settings on the actuator itself. I can see that we're driving in the open direction. The green indicator is telling me that we're driving open. And I'm going to be calibrating, looking at VR1 is our full scale calibration. So VR1 is up here next to the dip switches. And VR1 is where we're going to set the full scale for full open position. So I'm going to adjust VR1. I'm going to rotate it down. Okay, until it turns off, and then just until it starts to turn on. And that's where we're going to set VR1 for the position of the actuator. Then we want to check and set the feedback so that we can calibrate our feedback to show right where it's supposed to show at 20 milliamps. We're at 19.95 right now. That's pretty close. But the feedback is VR51, and VR51 is on the right side middle of the board. So I'm going to take and adjust this, and if you watch this trimmer here, you can bring this up to exactly where it will read 20 milliamps, or close enough. So we're at 19.99 or 20 on the feedback. So now we're fully calibrated on the open position of the actuator. So now let's go ahead and give it a 4 milliamp signal and calibrate the closed position. So I'll go down to 4 milliamps. The actuator should be driving closed. We know the valve is driving closed. We see the indicator driving counterclockwise to go into closed position towards the red closed indicator. Okay, so now the valve is gone as far as it's going to go as far as the cams are concerned. I can see in the feedback that we are not in the fully closed position. We're at 5.87 milliamps, and if I look at the valve, I can see that in fact the valve is still a little bit open. So what that means is I'm going to cut the power. I'm going to drive the valve closed, looking at the manual position indicator showing closed, going clockwise with the knob, with the override, and driving this until I'm watching the valve itself drive this until it goes fully closed. That looks pretty good. So now I'm in a full closed position. I don't want to turn the power on. I'm going to go ahead and calibrate the cam, and looking at the wiring diagram, we can see that the closed cam is going to be the number 2 cam, and that approaches the switch from the back side of the actuator. So I'm going to adjust the number 2 cam, and I'm going to move it off until I hear the click. And I'm going to set it right there. We'll go ahead and power it up and see where we end up. And the feedback is showing 4.05. I'm going to move it off cam a little bit, go open 25%. And then go back down to full closed. And now I can see that the valve is fully closed, it's in the right position, and I'm going to calibrate the analog response of the actuator. And looking at the closed position for full scale input, I want VR2, which is on the right side of the dip switch. So VR2, we're going to calibrate that until the red light just comes on. Right there. And that's our analog response set for the 4 milliamp side. And then VR52. VR52 is our full scale feedback. That's the one on the left side at the middle of the board. I'm going to adjust this and watch our feedback system, and I can bring this right on down. So now it matches perfectly. So let's go ahead and drive it out to 25% open. And we'll go back to 25% to full closed. Right on the money. Okay, so now that the analog settings for input signal and feedback are set, now we're going to go ahead and check the auxiliary switches. So we're in the full closed position at this point, and I can see by looking at the test box that we actually have the clockwise full closed auxiliary switches tripped, and I can check the setting of that by loosening the top cam and moving off to turn the switch off, and then moving in the right direction to the right. I can see the switch just barely comes on, and I'll move just a little bit further to make sure it trips before it runs into the end of travel. And then I'm going to do the same thing at the full open position. And I see we're off just a little bit on the VR1. So I'm gonna back this, or VR51, I'm gonna back this down just a little bit to get us back into calibration. Much better. So now we're at 20 and 20.05, and I'm going to check the auxiliary switch. I can see down here that the auxiliary switch is tripping. I'm going to loosen the cam up and check the position of it, and you can see moving it to the left is where it trips. I'm going to watch it trip and then move just a little bit further and lock it in. Now we've got the mechanical positioning set on the actuator to the valve. We've got the analog response for the input correct, the analog feedback is correct, and the auxiliary switches for full open and full closed is correct. So at this point, everything is calibrated on the actuator. We're going to go ahead and drive it back to the closed position. And we are at 3.99 to a 4-input signal. Auxiliary switch is tripped. We now have fully calibrated, valves in the closed position. This unit is ready to be put into service. And remember, don't lick the wires.